So in this video, we're going to take a look at our line of best fit or our linear regression. So we're going to actually use our calculators to help us calculate what is the best fit for our line. So when we knew that, one data point that we're going to get is called the correlation coefficient. And what a correlation coefficient is it's the number between -1 and 1 that's calculated to represent the linear relationship of two variables. Right? So the positive or negative sign tells you if the relationship has positive or negative correlation. And so if you have a correlation coefficient of -0.5, that means your negatively correlated data. As your x's are increasing, your y's are decreasing. Similarly, if you have a correlation coefficient of 0.67, that means that you have a positive correlation. As your x's are increasing, your y's are also increasing. Okay, so the absolute value of r, so if we disregard this sign, if it's positive or negative, the absolute value of it tells us how strong or weak the relationship is between the two sets of data. So the closer the absolute value is to 1, the stronger our relationship is, and the closer it is to 0, the weaker. Right. So that means that a correlation coefficient of -0.9 is a very strong correlation, but a correlation coefficient of 0.1 is not. So let's take a look at how we're going to kind of classify these things based on our correlation coefficient. So if we have, these are kind of grouped by your positive and negative. So as your negatives here, we're getting less strong. So you can see that this is pretty linear. This is still negative, but not as nice of a negative. So if we have correlation coefficient between 0.8 and 1, whether positive or negative, so look at both of those there, we're going to have a very strong positive or very strong negative. If we're between 0.6 and 0.79, it's a strong relationship. Okay, if we're somewhere between 0.4 and 0.59, we're moderate. That's both of these here. 0.2 to 0.39 is pretty weak. And then 0 to 0.19, whether positive or negative, is a very weak relationship. So keeping in mind these values here is going to be helpful for us when we are talking about those. It's just in increments of 0.2. So the first 0.2, very weak. The next 0.2, weak, moderate, strong, very strong, whether positive or negative. Okay. So we also could have no correlation here, which would end up in that moderate zone. Okay. So let's compare and contrast two sets of data. We're going to be thinking about those positives, negatives, intercepts. What is our correlation coefficient telling us? So if we're looking at these two models here, both of these models start at 0. So they both have the same y-intercept. So that is a good place to compare. And they're both increasing, and they're increasing at the same rate, right? So we both have the same slope. So we're increasing at the same rate. They both have positive correlation. However, this graph here, its correlation coefficient is 0.8. So we would classify that 0.8 as very strong positive correlation, whereas this guy only has a correlation coefficient of 0.5. So this would be a moderate correlation. So they both have positive correlation. They both start at 0. They both are increasing at the same rate, that's seen in their slope there. But this model here more strongly fits the data than this model because this is a very strong correlation. You can see our points here are a lot closer to following that line versus these points here a little more spread out. Okay, let's look at another comparison here. So again, let's look at those same things. So we're going to look at our y-intercept and say, oh, they both start at 0. So that's something we could compare. They're not increasing at the same rate, right? This model is increasing at a higher rate than this one, right? It has a larger slope. They both have positive correlation. So we could talk about that. And then they actually both have the same correlation coefficient. So that 0.75 is going to land us in the strong field. So we're looking at a strong correlation here, strong positive correlation. So these two have a lot in common. Their biggest difference is our slope here, which means here we're increasing at a faster rate than this one here. But both have positive correlation, both have strong positive correlation with that correlation coefficient of 0.75. They both start at 0. That slope there is our largest difference. Okay, so let's look at actually creating this ourselves here. So the first thing we want to see is there a relationship between the diameter of the sand granules and the slope of the beach? Okay, so if we're going to make our scatter plot, again, we're just plotting our things in relationship to each other. So we want to think about where should we put each thing and how are we going to plot those? So here we have diameter and the slope. This is our diameter. And this is the slope. So you can see here, they already told us the diameter is going to be the x. The slope is going to be the, this is an angle in degrees, our y value. So if we're looking at those two things, kind of look at your range here. These are all really, really small values. So I'm going to start at, let's see, we get up to 0.85. I'm just going to start at 0 here and just go up by 0.1s. So 1/10 each time. 0.6, 0.7, 0.8, 0.9, 1, 1.1, 1.2, 1.3, 1.4. And this is our diameter of the sand. And here is our slope of the beach. Okay, and these numbers, we go all the way from 0.63 up to 11. So there we need a little more of a range. I'm just going to go up by ones here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so once we have those points there, we're just going to plot our points. So if you want to pause to actually plot those points, that would be a great idea. I'm just going to throw these on here real quick like. We're just plotting all of these values that we have here. This 0.4273, that's kind of plotting there. And then 0.85, 11.3. Okay, so this is what our scatter plot looks like. It's always a good idea to kind of get a scatter plot to see, do you think there is some correlation? It does look like this has positive correlation, right? As your diameter is increasing, the slope of the beach is increasing. So let's actually utilize our calculator to find these things. So in your calculator here, I'm going to use the 30. There's ways to do this on the other calculators, but since the 30s are what you use in class, we're going to utilize that here. So we're going to enter our data into lists. So if you you get your calculator to do what you want to do. So we're going to go second data, and then we want 2 variables. And then we're going to put in our values here. So we went second data, create our 2 variables, and now I'm putting in all my x's. So make sure that you're putting these in your x1, and then my y1 is 0.63, x2 is 0.19, y2. So I'm just putting in each of these data points. It's going to be a little tedious, but take your time to enter them in your calculator correctly. 37.82. 0.235 goes with 0.88, 0.235, 1.15, 0.3, 1.5, 0.35, 4.4, 0.42, 7.3, 0.85, 11.3. Okay, so once we have that in there, we're just going to go back to data. Okay, and we are going to do second data. 1 second here. Let me get the correct button here.